So as before, we're gonna have the same question go around. So what is the total charge, Q total, right, of a, and right now it's gonna be a hollow cylinder. Hollow cylinder. So how are we gonna find what is the charge in a hollow cylinder? So let's do a hollow cylinder. And for the people of you that don't have a really good perspective of 3D dimensions inside their head, so first of all, you do have, otherwise you would not understand that I am here and the wall is over there. But it's really important to actually have this idea to look at 2D drawing and understand how it's look on 3D. And there's one way to do it is practice. Just see 3D object and then see how I draw them and do this back and forth again. So for example, we're gonna do a hollow cylinder, which is, this is a perfect example for a hollow cylinder. So how it's look like. So I'm gonna do the axis, and the axis is actually the corner of my room. So here is the corner of my room. So I'm gonna have here X, here Y, here the Z, and I'm gonna draw this cylinder. So cylinder, it's just do a circle over there and a circle over there, and it's a hollow one, so I need to do the hole. And this is, when I do this, I mean you cannot see it, also you cannot see this line, you cannot see this line, you cannot see the back one, right? So this is my cylinder, and my cylinder have some height. Let's say the height is H, and the radius of this hole is A, and the total radius is B. You see, like in the previous question. And I also have the charge distribution, the charge density that someone put inside this cylinder. So what is the charge density? So I'm gonna use rho as a function of R, yes. And it's equal to, how we do in calculus, these two things. If you are in a radius inside of the cylinder, you're gonna have 1 over R to the 2 multiplied by some constant and the difference between the radius, B minus A. And if you out somewhere else, otherwise, so you're gonna have 0. There's nothing, no charge in the place, no charge anywhere. Okay, so we have this cylinder and we have this equation. So what we want to find out? We want to find out what is the total charge. Okay, so how are we going to find the total charge? We're going to use the same equation we used before, which is the whole Q total equal to the sum of its parts. And what we need to right, to divide this object to many small chunks. Here it is, small chunks, small pieces, and then sum them up by obtain the integral, right? This one. So let's do it. Here it is. So how are we gonna find dq? I didn't tell you, but the unit of rho is actually charge per unit of volume. So it's to the third, meter to the third. In each cube of volume, I have this amount of charge. Okay? Think about it like, I don't know, a building. In each room, I have this charge, and all the room close by. Okay? So this is how we can find the charge. So we need to use dq, and we say the dq is equal to, actually let's divide this piece before we do it. So if you remember, we have here a small piece. Remember for the previous question, what this small piece was? Here, this is the ds. We said that this one have dr in size, right? This is the size, the length of this line. And this line was r d theta. But if I want to build this cylinder, this is not gonna be sufficient. Because if I'm gonna put something with no dimensions on top of each other, nothing would be built. So I want it to be like, let's say, a card. Here it is. So if I have a card, the card has some, you see, he has some thickness. And if I'm gonna put a lot of cards on top of each other, so I'm gonna have some height. So I want this piece right now to have also some height. So let's give it a pump. You see this is the height, and the height is in Z direction, right? So how are we gonna call this thing? We're gonna call it dz. And right now what we made actually is a Lego brick. We can put this Lego brick on top of each other and eventually have all the cylinder. So perfect, we have this, and right now it's not right to call it ds. Let's call it dv. Yes, ds multiplied by dz is actually dv. That's right, this is the value of all this idea. Perfect, so right now we can write down what is dq, right? dq equal to what? To the charge density multiplied by dv, the volume, right? The small volume, the small Lego brick that we build together. So this we know, it's equal to that, 1 over r squared rho node b minus a, multiply by this monster, which is, you see it's only r, and the r, the theta, the z. So I can get rid of this one, right? These two, I can get rid of. Let's get rid of these two and just write the r, the theta, the z. That's all, okay? So we got this one. This is our dq. Here it is, our dq. And let's get rid of this. And after we divide the cylinder, the shape that we have, what we need to do, we also don't need this anymore. What we need to do, we actually need to sum them up. We want to find not how much charge I have in these small pieces of volume with some thickness, some height, some area here. We want the whole. We want to understand what is the total charge in this cylinder, whole cylinder. So we're gonna use Q equal to the integral of this thing, which is 1 over r rho node b minus a, good, and the r, the theta, dz. And r is running from a to b, right? See it? I don't gonna count bricks that are not, that are in the hollow I don't care about, or outside this cylinder, I don't care about them. I only want the one that inside the cylinder. That's the idea here. But then I see these two. I see the theta and dz. So what we talked before, if I have another variable, I need to add more integrals to make it a fair game. So I need also to move around in theta, which is 0 till 2 pi. And I also need, what I need to move in the height. I'm gonna sum this kind of hollow plate, right? It's like the shooting plate. I'm gonna finish this one, up, next floor, up, next floor, next floor. So this is gonna be Z. So I'm gonna run from 0, the floor, and to the height, h, which is given also. So I need only to solve this integral. So what is the solution of this integral? Let's find out. So as always, I take all the constant outside, so this can go, all of this. So I have rho b minus a. Also you can see that I don't care here about neither theta and neither z. It can be in other question different, but in this one it's not, so it's an integral on a constant. So I can write just h and 2 pi, nothing changed, and I have integral of 1 over r. If you remember what is the integral of 1 over r, it's ln, right? And I also put the boundaries, so ln b minus ln a. And something nice about ln logarithm is that if I have an operator of minus between them, I can take it to the next step, which is division. So this thing is actually ln b over a. And if it's plus, so it's multiplication. It's going to be b multiplied by a inside inside here. Okay, so I have all the terms. So what is Q total? Q total actually equal to all these constants, which is rho naught h 2 pi b minus a multiplied by ln b over a. Perfect. So this was the question of the whole cylinder, and we learned actually in this question about the cylinder coordinate, which you're going to use a lot when you talk about capacitors and many other stuff. So what is the coordinate of a cylinder? It's moving r in theta, because we have in each floor a cycle, but we also need the dimension of the height, which with z. So that's what is important to take from this question. And now let's move on to the next one.